Good morning everyone. The topic that we are going to discuss is molecular shape. Welcome awesome students. Let's work together, do our best to learn as much as we can, and respect and support each other through all the challenges. Let's do this. We will learn VSPR theory, basic molecular geometry, arrangement of electron pairs. We will learn about the types of electron pair, force of repulsion of electron pairs, arrangement of electron pairs, and molecular geometry. The theory that we use to analyze the molecular geometry is VSPR theory, which stands for valence electron pair repulsion theory. There are two types of electron pair, which is lone pair and bonding pair. This electron pair will determine the geometry of the molecule. The force of repulsion between the lone pair and the lone pair is the strongest, followed by lone pair and bonding pair, and lastly is bonding pair and bonding pair. There are 5 types of basic molecular geometry, which is linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. Before we proceed to the problem solving, there are a few guidelines in predicting molecular geometry. Firstly, draw a possible Lewis structure. Secondly, establish the electron pair geometry. Then count the total number of electron pair. Lastly, use VSPR to predict the molecular shape. Below shows a conversation between Xiangning and Daryl in solving problem of molecular geometry.
Yes, Daryl, I can't wait to know all the information in order to draw a Lewis structure. And from what I know, we have 5 basic molecular shapes: trigonal planar, trigonal pyramidal. What is the another 3?
No worries, I got your back, Xiangning. There are 3 more basic molecular shapes you left, which is tetrahedral, octahedral, and linear. See, this is one of what we are talking, linear shape. It is in line, that's why we call it linear. It is 180 degrees as it is in a line.
Oh, I see. How about the second one? Do you think it looks like a triangle?
Yes, it is so true. That is why we call it trigonal planar.
Well, as all we know, 360-degree causes a circle here. That is why we need to divide it into 3, so 120 per angle.
Yes, you are right. Let's move to the next, tetrahedral. As we know, tetra means 4, so tetrahedral contains 4 pairs of electrons, neither lone pair or bonding pair.
But I'm still confused with the molecule with 5 electron pairs. What is that? Can you explain about it?
Molecular geometry with 5 electron pair is known as trigonal bipyramidal. The bond angle is 90 degrees for the first 3 molecular geometry. Only the molecule with 2 bonding pair and 3 lone pair has bond angle of 180 degrees.
Oh, I see. Thanks for the explanation, but how about the molecular geometry with 6 electron pair?
Molecular geometry with 6 electron pair is octahedral.
Oh, okay then. So let me introduce you the several types of molecular geometry when bonding pairs interact with lone pair.
Identify molecular geometry, we can do it based on 2 factors. One is number of bonding pairs, while the other number of lone pairs. The presence of lone pairs will disrupt the system, causing the shape to change. The arrangement of electron pair will be different from molecular geometry. First, when we have 2 electron pairs, we will have the basic electron shape called linear. When we have 2 bonding pairs but no lone pair, number of electron pairs still remain 2, while the basic shape and molecular shape will still be linear. Second, when we have 3 electron pairs, we will have trigonal planar, which looks like a triangle. So when they have only 3 bonding pairs but no lone pair, yes, the molecular geometry still remains trigonal planar. However, when there is presence of lone pair, everything changes. 1 bonding pair and 1 lone pair will still have 3 electron pair and trigonal planar as its basic shape, but the molecular geometry will change. It is due to the presence of lone pair. The lone pair will disrupt the shapes, or we can call it as system. So it changed it from trigonal planar to V shape, or we call it as band. Then let's move on to the next examples, which is 4 electron pair series. It acts as a tetrahedral at first. So basically, when it has 4 bonding pairs with no lone pairs, the molecular geometry and the arrangement of electron pair will still be the same, which is tetrahedral. But it goes different when 3 bonding pair and 1 lone pair is in the system. It will cause the change in shapes due to the disruption of lone pair or the bond angle. The shape will turn to form trigonal pyramidal. And lastly, when it has 2 bonding pair and 2 lone pair, the changes in shape still happen and somehow more bigger as 2 lone pair is changing the bond angle. So it lastly forms band or V shape. When we have 5 electron pairs, trigonal bipyramidal will be the basic shape of the arrangement of electron pair. So when there is no lone pair but only 5 bonding pair exist, the molecular geometry remains as trigonal bipyramidal. But when it has 4 bonding pair with 1 lone pair, shape change to distorted tetrahedral as the lone pair is interacting with the bonding pair on the central atom. And also, when there has 3 bonding pair and 2 lone pair, shape will still change, which turns to form T shape. And last but not least, with 2 bonding pair and 3 lone pair, shape will turn out to be linear. Lastly, we have 6 electron pair that assist in shape of octahedral. It goes the same as well when no lone pair shape remain unchanged. When there is 5 bonding pair but 1 lone pair, shape change due to the disruption of lone pair. So the shape turns to form square pyramidal, while the system with 4 bonding pair and 2 lone pair forms square planar. question given asks us to draw the molecular geometry of the I3 negative. So I all of us know that I has 7 valence electrons and that has 3I, so that's why we times 3 with 7 and then we get 21. For the negative charge we need to plus 1. So we get 22 electrons in the system. This is the total number of electrons that will be found in the later level structure. Secondly, we will draw the level structure. So we need to draw everything in a linear shape first. As we have 3I, so we draw 3I here. Pick 1I as your central atoms and the other 2 octet them. So we add on electrons to make them in octet form. After that, we count the number of electrons they have now in the system. So we have 16. One bond consists of 2 electrons. So by minus 22 with the 16, we have 6 electrons left, which means that this is the lone pair that we need to add in the central atom, like what I'm doing right now. So the number of electrons have all been found in the system. So now, the third step, we need to count the number of bonding pairs and lone pairs. So we have 2 bonding pairs and 1, 2, 3, we have 3 lone pairs. So we have 2, 3, we got 5 electron pairs. With 5 electron pairs, which leads us to the basic molecular shape trigonal bipyramidal. However, the shapes will not remain as trigonal bipyramidal as there is the presence of lone pair. The lone pair will disrupt the shape of the level structure as the bond angle will increase or decrease. So, as the basic shape is trigonal bipyramidal, we need to draw I as a central atom first, and then draw the another 2I, and then we leave all the lone pairs at the center. So you should be found that the shape is in linear, and the degree is 180 degrees.
In helping students for better understanding, there are few resources provided below. To master molecular geometry, students must complete quizzes provided and go through the molecular shape tutorial and notes given. Contact for questions and clarification.